Alright, so I'm going to review nomenclature 6 with you for those that prefer that way of going over some answers. So the first thing is phosphoric. Remember, ic comes from 8. So phosphoric would come from phosphate. It's an acid, so you put +1, and then you put phosphate, which is PO4 minus 3, and you cross your charges. This right here, calcium is +2, and bicarbonate is on your polyatomic ion sheet, it's -1. And then I cross my charges. Zinc is +2, hydride is H -1. Sulfur dioxide is 2 nonmetals, and for 2 nonmetals you have to use prefixes. Sulfur doesn't have a prefix, so it's only one of them. Oxygen is di, so it's 2 of them. There's no crossing your charges on nonmetals. This next one is a hydrocarbon because it ends in ane. So alkanes take the formula of CnH2n+2. And since prop is 3, it would be C3H 2 times 3 plus 2. And that's how I get C3H8. This next one, potassium is +1, and perchlorate is ClO4 -1. This one, 13. This Roman numeral tells you the charge of nickel, so it's +3, and sulfate is -2. Mercury is +2 because of this Roman numeral, and hydroxide is OH -1. Big mistake here, you guys forget to put hydroxide in parentheses, so just remember that for your test. Magnesium is +2, nitride is -3. It ends in ide, so it's just the element symbol by itself. Here we're using prefixes. Tetracarbon, diphosphide, so there's no crossing charges. Those prefixes tell you how many of each we have. Hydrogen peroxide. Hydrogen is +1. Peroxide is a polyatomic ion on your polyatomic ion sheet, so it's H2O2 once you cross charges. And you cannot reduce this one because you can only reduce the charges that you bring down, and the charges you're bringing down are a 1 and a 2. This next one, Pb, is +2, and Cn is -1. An octane, it's an alkane because it ends in ane, and it's oct, so it'd be C8H 2 times 8 plus 2. I'm going to just go up here. So the hydrogens here, you have more hydrogens than double the carbons, so you know it's going to be an alkane. And then you have 6 carbons, so that makes it hexane. This is a tertiary. So all you do, you put your tin, and everything that comes after the tin has to be found on the polyatomic ion sheet, and it's carbonate. Tin needs a Roman numeral. So you have to go over here. Carbonate is -2, and you have 4 of them. You have 2 of them, I'm sorry. So that's -4, so tin had to be +4. So that's why it's tin Roman numeral 4 carbonate. This right here, it's an acid. So you have to figure out the name of what comes after the acid. And it's sulfate. 8's become ic, so it becomes sulfuric acid. This next one is tertiary. So you write down your sodium, and everything that comes after the sodium has to be found on your polyatomic ion sheet, and it's thiocyanate. This is 2 nonmetals, so you have to use prefixes. Just to review, nonmetals are to the right of the staircase. So if you have 2 elements coming together to the right of the staircase, you have to use prefixes for them. This right here, it's sodium, and this is peroxide. Sodium oxide would be this, Na2O, This has Na2O2, so that tells you this is the peroxide found on your polyatomic ion sheet. This is a tertiary, so write your metal name, and everything that comes next has to be found on your polyatomic ion sheet. Cadmium nitrate. The next one is a tertiary, mercury sulfate. Mercury needs a Roman numeral. So let's go see what the charge of the sulfate is. It's -2, so mercury has to be +2. So it's mercury 2 sulfate. This one, next one is a binary. So you just put the element names, and the second element name has to end in "ide." Manganese is a transition element, so it has to get a Roman numeral. So it's manganese, Roman numeral 2 oxide. This next one is a tertiary. It's lead, Roman numeral 4 hydroxide. Number 22, it's a tertiary. So you know you have copper, and everything that comes after copper has to be found on that polyatomic ion sheet. Copper needs a Roman numeral. So look at your carbonate, it's -2, so copper has to be +2. Copper, Roman numeral 2 carbonate. This next one is 2 nonmetals, so you have to use prefixes that tell you how many of each of them you have. So it's dichlorine heptaoxide. If you have heptaoxide, that's fine. And this next one, it's an acid because it begins with H. So you have to figure out the name of what comes after the H, and it's sulfite. And ate becomes us acids. So sulfite becomes sulfurous acid. Let me move it down a little bit. Oh, can I move it down? There we go. Okay, so we're going to go back to this side. This is just calcium, which is +2, and sulfide, which is S-2, but make sure you reduce this one because the 2's can be reduced to 1's. This next one, copper, is +1 because of this Roman numeral. Dichromate is Cr2O7 -2. Cross your charges. This next one, cesium, is +1. Sulfide is -2. Cross. This next one is a hydroic acid. So hydroic comes from ide. So first of all, it's an acid. So you start by putting H +1. And hydrofluoric would come from fluoride, which is just F-1. So it's just HF. This next one is an alkane because it ends in ane. F is 2, so it's going to be C2H, 2 times 2 plus 2. So it's C2H6. And acetic, first of all, it's an acid, so it begins with H. Acetic comes from acetate, which is C2H3O2 -1. This next one, methane, first of all, you know it's a hydrocarbon, and you only have 1 carbon. So 1 carbon is meth. How do I know it's an alkane? Because your hydrogens are more than double your carbons. This next one, calcium, it's a tertiary. That means anything that comes after the calcium has to be found on your polyatomic ion sheet. So it's calcium bromate. This next one's a binary, so it's just the element name, strontium, and the second element ends in ide, so iodide. The next one, you know it's an acid because it begins with H, so name what comes after the H, and it's perchlorate. And 8 becomes ic, so it's perchloric acid. This next one's a tertiary, so you know it's potassium, and anything that comes after the potassium has to be found on your polyatomic ion sheet, and it's permanganate. And this next one, you know it's a hydrocarbon, and your hydrogens are more than double your carbons. So that means it's an alkane. So 4 carbons equals bute. So it's butane. So I hope that helped you going over that. If you are still reviewing this and you have any questions on any of them, please let me know, and I'll be glad to review it more with you. The last worksheet you have is the nomenclature review, and if you do the front, the answers are on the back, and if you do the back, the answers are on the front. So you can check your answers right away and see if you're doing it right. All right.